we'll now talk about the flyweight design pattern. The flyweight design pattern is a memory optimization design. The main objective of the flyweight is to basically help you conserve memory so that you don't pull in large data structures into your main memory when your program is running. This can be a huge performance improvement. There might be times in your program where you find that you have different instances of objects which share most of their state. So most of these object instances share values for a large proportion of their state, and it's only a few values which are actually different. Now if you instantiate all these objects and they instantiate all the data structures which are common once for each object, this can be a huge memory hog and then slow down the performance of your system. What we want is a way by which all these shared data structures are instantiated exactly once, and all the objects which need these shared data structures hold a reference to it rather than instantiating it each time for every object. This is what the flyweight pattern is about. Let's see an example and see how this works out. In this example, you basically have a factory which creates insects. There are over 1 billion species of insects. Now, it's very obvious that there is a whole bunch of state which every insect shares with another. So all these billion species of insects have a lot of common state. Let's call this extrinsic state. And now within each insect, the locust, the cockroach and the ant, it has an intrinsic state which is specific to that insect. The flyweight pattern basically says that this extrinsic state should be stored as an external data structure. It should not be within each insect, because each time you instantiate an insect, you'll hog the memory for the extrinsic state. Instead, you just set up the extrinsic state that is shared exactly once, and then every insect can hold a reference to that extrinsic state and have its own intrinsic state. The extrinsic state is just passed in to every insect. This way, creating an insect is very easy because you don't have to hold all this memory, you don't have to allocate all this memory to every insect. Thus, memory optimization, which leads to performance optimization. Instantiating an insect right now, set up like this, is a flyweight operation. Let's say we have two strings, Tweedledee and Tweedledum. What we want to do is to test these two strings and see whether they are equal. So we want to do an equality test on these two strings. How much work do you think will be involved? Well, the answer isn't yes or no. The answer is that it depends. It depends on the programming language. Let's say that we were programming in C or C++. How do we compare two strings for equality in these languages? The way we do it is one character at a time. We'd go through every character in each string and test whether that character was equal. This makes string comparison in C or C++ order of n, where n is the length of the string. By order of n, we mean that we have to make n comparisons to check whether the strings are equal. But let's say we're doing this in Java instead. The cool thing about doing it in Java is that it would be an order of one operation. We actually don't need to check for every character in a string. Just one of will be able to compare whether the strings are equal. We'll talk about why that's the case. Strings in Java are treated a little differently than regular objects. Java, like many other modern programming languages, makes use of something called string interning. String interning is kind of an optimization mechanism for storing strings. Typically, in any program that you write, you'll do a whole bunch of operations with strings. In order to optimize those operations, we use string interning, which is a built-in part of the Java programming languages. Java developers realized that strings are commonly used, and to optimize its performance, this was their solution. So what is string interning? Strings in Java are immutable. This means that Java only stores one copy of each distinct string value. So if you have the value hello, there is just one copy of it. You might assign a string to the value hello multiple times in your program, but it all points to the same copy. This is string immutability. This also means that if you add two strings together to generate a third, the original strings are not affected in any way. Java simply creates a new distinct value for the third string and sets it up. This is what makes strings in Java immutable. Now, how do we test whether two strings are equal? The thing to do to test for equality between two strings is to simply test if they are the same object. All equal strings or all strings with the same values point to the same location in memory, which is where Java has stored that string with that distinct value. All you need to do is the object identity test to test for string equality. Since string variables are actually references to these immutable strings, the object identity test is enough. If you modify a string variable, what happens then? When you modify a string variable, a new underlying string value is created. So the original value is not disturbed, a new underlying string value is created, and the string variable is set to point to that new value. So when you create a new string, a new value is created in memory and the string just points to that. The original value remains undisturbed. Notice how by making the strings immutable, using string interning, we actually conserve memory. If you have a whole bunch of strings initialized and they all have the same value, they point to the same space in memory. This immutability of string objects is a pretty standard part of many design languages, many programming languages. Java, .NET, Python, Ruby. This is an example of the Flyweight pattern. Let me summarize. Using the same piece of memory to hold the same string value, a distinct string value, and every variable which wants that particular string value points to the same space in memory. Sharing of memory in this way so that unnecessary string objects are not created is an example of the Flyweight pattern.